Hello fellow AGD coders, welcome back to another video. It's been a little while, I hope you've all been keeping well. Just finished my new game, Roust, which I hope you've seen and perhaps played. And so I thought it was about time I came back with another video. Some of you may have seen on the Facebook page that I've posted a few fun demos, and I thought you might like to know how those were achieved. So we're going to take a look here at how we use the detect block system that I worked on to create a few different styles of block. And the first one that we're going to look at is this one here, as you can see, and this is a crumbling block. And this is obviously very much a feature of Manic Miner, but not only Manic Miner. There are a few other games that feature it, although none immediately spring to mind. So anyway, it's a good fun feature to add a little bit more variety to a game. And this is the reason that this is really possible is the fact that I'm going to show you now a little hack which allows you to create more than the standard 7 block types, so that other block types can be detected. And because there are lots of different block types, then you can do much more complex tricks with AGD. So let's look first of all at how we do that, how we actually set up and create some new block types. Okay, so let's go into the block editor and look at the different block types that we're already familiar with. As you know, we have empty, platform, solid wall, and then we have ladder, fodder, deadly, custom, and water, and those are numbered 0 to 7, and the detect block routine can detect any of them. But obviously we have a limit. Once we get to water, then it goes back to empty again. So from 0 to 7, that's all we can do, as you can see here. So what I'm going to do now is I'm going to create a set of blocks for our melting block. So we'll start with one here at the top, and then we'll go on to the next one. So I'll copy it and create another block, and then I'll paste the previous one in. So I'm going to make, I think, 5 different blocks here. You can make the number that you want. You could have more or less depending on the effect that you want to create. So yeah, but I'm going to make 5 here, so we'll start with this one, and we'll make that one fairly solid like that, and then we'll drop down 1 level so that it looks like it's collapsing a little bit, just like this. Okay, and as I do this, I'll just also explain to you that to do this you're going to have to load in the ASM, the assembly code for detect block routine. It's available on my itch page, and the new version, which also detects attributes, which is quite a useful additional feature for some of the other demos that I'll be showing later on. So you need to load that into memory to run the assembly. And if you haven't seen those videos, then you should go back and watch them. There are 2 videos. One of them is about just standard detecting blocks, and the other one is using water blocks. But now what we're going to do with this one, of course, is we're going to create our own brand new different kinds of blocks which don't actually exist in AGD. So as you can see here, I'm making a little bit of progress. I'm just making a collapsing block. You can, as I said, it doesn't have to be a collapsing block as in the ones that you have in Manic Miner. You can have a different type if you want, maybe some cracks that start appearing or anything like that, really. Those kind of things are all possible. And we'll just finish off here. I think that one will do, and we'll just go back and just have a look at it there. You can see if I browse through them, you can see it there. That animation is reasonably okay. Okay, so now that we've got that shape, then the next thing that we want to do, of course, is look at changing the type of block. And currently it's just an empty block, But what we want to do then is create some new block types, block 8, 9, 10, 11 and 12, so that we've got different states that we can test for. The key to having crumbling blocks really is the ability to detect the state of the block. So we'll actually create 5 different types. To do that, we need to know where in memory the type data for the blocks is stored. And we can actually read this just as we have done before with sprites and objects and so on. There is a pointer that we look for, and it's just down here at 7D40, and the exact location is in fact just around about here. Just hang on a second, I think it's 7D43. So these two numbers here, as you can read them off, so 94 and 9C there. Okay, so let's first of all remember the order, 94, 9C, so 94 first, then 9C. We'll convert it in our hex converter here. There you go, so it's 38044, and that tells us the first the start of the type data, which will be, so that will be the address for block 0, for the type for block 0. So if we jump back here, then we'll see that's block 0, and the type there is of course empty space. So we're going to have to add 1, 2, 3. So we're going to have to add 3 to our number that we read to know the type that block is. So well, it's pretty easy to do, and we'll now go to poke the memory, and so we're going to basically poke this address. But first of all, we have to add 3, so 38047, and we're going to poke this with a value of 8. So we're setting this block to be type 8, which obviously is beyond the normal scope of AGD, but as you can see there, we'll get this kind of gobbledygook garbage thing here, but don't worry about that. That just means that AGD doesn't know what block type 8 is, and it's trying its best to tell you what it is, but it won't crash or anything like that. So obviously then what we need to do is go to the next block that we created, which we know will be 1 byte ahead at 38048. We'll set that to be block type 9, and we'll basically just repeat this action another 3 times, so that we've got each block to be a different type. So 38049 will be 10 and 11, and of course finally 12. So what we've done here, we've created essentially we've set these blocks to be 5 different block types that aren't normally available in AGD, but our little block detect system will be able to detect those types of blocks, and we'll use each one of those to indicate a different state of crumbling block here. So as you can see, browsing, there's a little bit of screen corruption, and it's reporting, well, it doesn't really know, as I said, about what you've done there, but just ignore it. As long as you know that you've poked those values, then you know that those blocks will be detected as block types 8, 9, 10, 11 and 12. So yeah, now that we've done that, of course, we just need to set up a little test area so that we can see if it's working properly. And what I'm going to do, actually, because this is an in-depth video, I'm going to show you some of the problems that I encountered when I was first working on this, and hopefully that will prove educational to you. So I'm just going to set up a little test area here with a few melting blocks, and I'm also going to test here with blocks in a slightly different state. So obviously with this system you don't just have just a melting block, you can have a half melted block or something like that as well if you use the blocks to create the effects. So the first thing that we need to do here is detect the blocks directly underneath the player and make sure that the player doesn't fall through them, because obviously these blocks, as far as AGD is concerned, are completely invalid and they'll just be ignored. So we take the line and column, we divide it by 8, and that will set us up with the position of the sprite, so that line and column match the top left corner of the sprite. Rand here is a flag because I'm going to be checking two different blocks, so if either of them are correct then it will be set. We add 2 to the line so that we are directly beneath the player, and then we run the detect block routine, and we're going to put it on a repeat, so we'll run it twice. And we are checking if the opt value, which is the value returned by the ASM call, if it's above 7, so 8, 9, 10, 11, 12, any of our blocks, set rand to 1. And rand will be set to 1 and by either of them, so if it's either the block below the player on the left or the right, we'll set to 1 and we'll stop the player from falling. So that's the first step, and as you can see here, this is what we're doing. We're basically monitoring here directly below the player, 2 lines below the player effectively, and as you can see here, as the player now moves across the empty block, they are now being treated as though they are platforms. In other words, they are stopping the player from falling. So that's our first step, and that's working fine. So the next thing that we have to do then, of course, is we need to tell AGD that every time that the block is hit by the player, it should basically add 1 to itself, so that block 8 becomes block 9, and 9 becomes 10, and so on, and that will basically create our sort of crumbling or melting effect. So I'm going to put that code in here now. So this is the point here, as we can see, where the block is detected, and it knows that it's hitting a new type of block, one of the melting or crumbling blocks, and it's setting the flag. So this is the position where we need to tell it to start the process of changing the block to a different type. So what we do is we basically add 1 to the opt value. So as I already said, type 8 becomes type 9 becomes type 10, and so on. Now obviously once we get to type 12, we need to then, if that increases, it will become 13, and we'll set it to 0, because that means become a completely empty block, a blank space. If not, we'll subtract 5. Now the reason we do that is because the blocks are stored concurrently in as type 8, 9, 10, 11, 12, but the actual block numbers are 3, 4, 5, 6 and 7. So to get the corresponding block according to the block type, we need to subtract 5. Then once we've put a block, we need to subtract 1, because put block always moves column across by 1 space, so we'll subtract that, and then we will basically it will loop over and repeat itself. Now it's always a good policy here, as I'm realizing here from my check, that I've actually got one end if too many. So it's always a good policy when you've got nested ifs like this, can get a little bit complicated. Before you actually run the code, you might as well just go back quickly and check that everything is lining up as it should, because as you can see here now, yes, that end if matches, and that one matches, and the repeat matches, so that means we should be okay. And yeah, so let's just take one last look. As I said, we are adding 1 to opt. If it's above the range, then we're setting it to 0. We are subtracting 5 here, because as I said, 5 is the difference between the block type numbers and the actual block numbers. I think what I'll do, actually, I'll go into the code. We'll go back into the blocks, and I'll show you exactly what I mean if it's not clear. So as you can see here, this is block type 3, and it's block number 3, and it's block type, as we remember we set it to 8, and of course the difference between 3 and 8 is 5. So as you can see here, yep, as we go across, it is crumbling away. It's actually going pretty fast, and we'll look at how we can address that in a moment. But essentially, as we can just test there, that's absolutely fine. Yep, and it is. There are some transitions there, even though it is going quickly. And there, straight away, you can see the first problem, and that is that we are putting blocks in a place where the player is currently positioned. In other words, the blocks are crumbling when the player isn't actually standing on them, and I'll demonstrate that by putting our little character here underneath and showing you what happens. As you can see, if I jump, now it's detecting the block and it's basically trying to do the animation, but it's encountering a player sprite and it's creating a lot of screen corruption, which is definitely not something that we want. So let's just see, how do we avoid that problem? Well, basically what we need to do is tell AGD that you only want the blocks to collapse when the player is exactly lined up, and we know that the characters are 8 by 8. So what we'll do is we'll use another variable. This is a temporary variable object. We'll match it to the line and we'll multiply it by 8. And if that number is equal to x, that will tell us that x is divisible by 8. And what that means is that we'll only activate the melting or the crumbling when x is exactly divisible by 8. In other words, it's directly below. So we'll add this code in here. If x equals object here, and we'll just put another endif in here, and that should basically stop it now from yes, and you can see there, okay, it now no longer melts when the block is when the player is positioned in the wrong place. So we've solved our problem with screen corruption, but as you probably noticed, we now have another problem, which is that it's stopping the player from falling when it's halfway up, like as you can see here. So the player is not jumping properly, and again, so we need to do the same thing for the stop fall. We need to tell AGD only stop the fall when the player is exactly lined up. So this is the next problem that I faced. So let's take a look at how we can address that problem. What we're going to do is essentially tell it to only stop the fall when the player is lined up. So when x is equal to the variable that we set, it will stop the fall. Otherwise, the player will continue to fall. Let's put that condition in here. So here in our stop fall, we will put another code in here, which will be if x equals object. So if x is divisible by 8, remember, then stop fall. Okay, so let's try that. This was still a process of experimentation for me, but as you can see, now the player can jump and will jump onto the crumbling blocks. So that is that's a lot better, isn't it? Basically, we're not getting stuck in the middle. It's behaving as the player expects it should, and that's really the key here to any good game. You really need to make sure that that your game is behaving in the way that the player expects, because if the player can predict what's happening, then he can anticipate it and respond accordingly. So that is pretty important when it comes to enjoyment of games, is if a player, he or she, can predict exactly what is going to happen. Okay, now the other thing, as you can see here, I've got an animation timer. These are very common in AGD, and you can apply this to the block as well, because the blocks are melting very quickly. So we'll add another condition in here. If a equals 0, and we'll put an endif in here, and that should be enough to slow the blocks down. Let's take a look at that. And there we go. Yep, so that's great. We have managed to slow the blocks down, and so you've got complete control there. Really, you can use a different variable if you want. You could use a player param or a specific variable to control the speed of the melting blocks, and you could have blocks melting at different speeds depending on the screen. You could create different types of melting block as well, some that melt more quickly than others, and so on. So now we've got the basics down. I'm now going to try and see what happens when we have a large amount of blocks, and make sure that the player can climb through them. So let's just set the player up here, and we'll now see another problem that we encountered. So what happens here is that when one block is directly below, the problem here is that the jump table is such that the player is actually, what's happening is the player is actually slipping through the position where it's divisible by 8, and therefore it's not being detected anymore. So obviously that in itself is also a problem. So one of the ways that we could solve that again is by using this object comparison, and I'll show you one way that we can do that here. This is the first way that I tried anyway. To be honest, this is still a process of experimentation, and I haven't perfected it yet. We're getting pretty close though. So what I've done here is set let x equal object. So in other words, if you encounter a block, then set x to be divisible by 8, and the effect of that is that as the player falls and it hits the block there, it's actually resetting itself a little bit to the position and lining itself up, and that is more or less achieving the effect that I wanted. So that's pretty good. There were still further issues though with this, and there was another issue, I think, with and I'll show you it here. I think if I put a block up here like this, then when the player jumps, it's getting lined up with the one above. So he's getting sort of lifted and sucked up a little bit. And to be honest, I'm still pretty much working out exactly what to do about that. I think I've managed to crack it, and I'll probably put it in another video. But basically what's happening here is that I think I need to detect exactly the position of the block directly when the player is just 1 pixel above or below, something like that. Within a certain range, I can sort of tweak the conditions, and I think we'll probably be able to figure that problem out as well. But it's not a huge problem, and I'll do another video once I've figured out a good solution to that. Okay, so let's finish with the review with the code. So the first thing we do is we detect we set the line and column, and we divide by 8, and that puts that gives us the squares that we want to detect. We also then create a variable which we can test against x to know that it's divisible by 8, which will tell us that the player is positioned exactly in place directly above a block. We then use a flag to test for both, and we add 2 columns so that we look directly below the player. We then run the ASM and we check if it's above 7, we set the flag, and then if x is directly lined up, we basically cause the blocks to crumble by adding 1 to opt, and we create an animation there by using put block, and then finally we subtract 1 from the column, and that basically takes us back to the start routine and repeats itself. So that's kind of it, but I thought it might also be fun just to show you a couple of extra things as well that you might want to try. You can adjust the sort of range of the crumble or melting effect, and for example here, if I put a condition in here where I basically check if the column is greater than 2 and subtract 2 from the column, instead of looking directly below the player, then I'll be looking just a little bit back from the player as the character moves from left to right. And as you can see, what that means is it creates a sort of effect where the ledge starts to fall after the player has already passed it, like that, in a sort of Indiana Jones kind of effect where he's run across and then it started to collapse and then now he can't get back. So obviously we need to work that in both directions. So as you can see here, image 0 and image 1, so we should test for image 0 and image 1, and if the player is moving from left to right, as we see here, then we will cause the blocks to collapse in that way, and then we'll also test it in the other direction. So we'll then say if what should it be, 21, yeah, because plus 2, so that would be 23, that would be the maximum. So actually I think it should probably be 22, but that's okay, it's just a little test, you can change it. Yeah, add 2 to column, and that will mean that as we move that way, as you can see, the blocks start to collapse. And see if we can also do the same effect in the other direction. Yeah, I think that's, yeah, it's pretty much working. So play about with that, you know, this is all part of the fun, just to try a few different experiments, just to see what will happen, really. So that would be one thing to try. And another thing we could do is we could change the range and the amount of blocks that we're actually testing. So at the moment it's only impacting on 2, but we could make the sort of range of effect increase. And what we'll do then, we'll delete that effect, and we'll change this repeat here to a 4. And that means it will be checking 4 blocks, including blocks directly in front of the player. And as you can see, that's working. And obviously the player has more impact on the environment in that scenario. And what we should probably do, I guess, is we can probably just subtract 1 from the column. So we'd be checking one column behind the player, 2 columns directly in line with the player, and 1 last column in front of the player. So if we subtract 1 here, we should probably check that it's above 0, but we know that there are no blocks right in that far side anyway, so it shouldn't be a problem. And there you can see we are now melting or crumbling a much wider area. So that could impact on the sort of difficulty level or whatever effect you want to create, you know, depending on the kind of game that you're working on. As I said, play about with all of these things. That's really the key to having fun and learning. Right, well, I think that's pretty much it. I hope you found it useful. I hope to see it in a game. And in the meantime, as always, keep enjoying the Spectrum, keep enjoying AGD, and happy coding. Bye bye.